Hi everyone, thanks for joining us for this tech session about infrastructure scalability in times of pandemic. Julien and I will present you the session. We are both members of the site reliability engineering team at Opendatasoft. So first, we'll have a quick overview of the agenda. The first part, I will present you general consequences of the pandemic. And the second part, Julien will talk about HTTP caching. And the third part, we'll discuss the availability of the HTTP caching feature and its possible evolutions. And at the end, you can ask us any question if you have some. So the first part, pandemic consequences. The first slide will be what hasn't changed, in fact, because of the pandemic. First, regarding our team, the SRE team, we are a distributed team already. We are used to work from different locations. For example, Julien is working from Nantes, where I'm working from Paris. And so when lockdown occur, working remotely from our homes is not that difficult for us. We are used to work remotely using chats, conferencing, and so on. Regarding the infrastructure, we are 100% cloud-based infrastructure. So in the same way, it's not an issue having movement restrictions and so on, because our cloud providers handle all the physical maintenance of the infrastructure. They do have business continuity plans, which allow them to handle all the physical maintenance. So we rely on them for that. So overall, we can say from a team point of view, we didn't have a major impact for organization. We saw anyway some changes. If we didn't saw some of them, the session wouldn't be. Regarding the service usage, generally speaking, data sharing increased a lot because of the pandemic. Governments, civil society, scientific communities shared a lot of more data. In fact, they need them to help them to address various objectives, such as enhancing a response to the pandemic, reassess various measures, or help with the recovery. If you are interested with that, we have a blog post speaking specifically about that, so you can check on Opendatasoft blog. But one use case, one specific usage did impact us. It's the COVID-19 dashboards published by our customers. You can see one on the right of the screen, and it put a lot of strains on the infrastructure. In fact, such dashboards are regularly and frequently updated, and it's all the users tends to know when they are updated, and they come to see the refreshed data at the time. So for example, if you know that dashboard is updated at noon, you'll come at noon and will hit refresh button until you get the refresh data. So this kind of behavior, coupled with a very high popularity of such dashboard, generates a lot of spikes on our traffic. For example, you will see on the next slide few days of traffic, and on the left you have usual background traffic, and you can see on the middle on at the end of the week on Sunday a spike representing the French municipal elections results. Some cities in France use our infrastructure, our platform, to publish their results. And on the right, something completely different in terms of traffic. It's Mexico City, which published COVID dashboard. And as you can see, the spike is much more longer, and is much more higher. So we had to cope with such traffic. If we zoom out a little bit on the next slide, you will see a few months of our traffic. And on the left, early March, you see very regular traffic with some nice cycles. We see day and night. And at the end of March, the green graph, you see Castilla y León, which published its COVID dashboard. We had a nice session previously on the main stage talking about that, and it generated a lot of traffic we see compared to what we are used to. And we can see that it lasts on the following months. On the right of the graph, it's the part we discussed earlier. You see the French elections again, and well, you nearly see them. It's the orange graph, a small spike, which is nearly ridiculous compared to what Mexico City spike generated at that time. So this is really this kind of spike which were hard to handle for us. So we had to react, and what we did is scaling up the host to react quickly. So we simply configured with our host provider bigger server, more powerful server, in order to handle the load. And it did it. It was okay to do so. So fast, easy, nearly no downtime. But the big drawback is that it cost us a lot of more, and it's not efficient at all, because having such big servers to handle few spikes is not what we want to do. So we decided to design and implement a solution based on an HTTP cache, and that's what Julien will talk about.
Thanks, Florent, for the introduction and the context. So I'll explain to you what we did actually to handle that much traffic. So first, the easy way to handle this is obviously to throw more money at it. So by scaling up the servers, but obviously it costs a lot more money. So we try to do something more intelligent, more interesting. First, we'll see what happens when you request a dashboard. Actually, it generates quite a lot of HTTP queries. So for example, here, we are seeing a graph where Alice on the right, I can show you, sends a request. Actually, it's a lot more, but we'll make it easier to understand with just a request for a dashboard. Acts a request to our reverse proxy server. This is our server that first handles all the queries and checks for each domain it is, and checks a lot of things, answers the encryption, etc. And then the reverse proxy forwards the request to the backend server, which actually handles generating the result and interpreting all the query parameters, etc. For example, when you ask a dashboard on the home page, for example, on a portal, we generate all the content at the moment of the query, and it costs quite some time and CPU power. And then the backend server works hard to generate this content and sends it back to the reverse proxy, which sends it back immediately to Alice. And then it's rendered in a browser. She sees the result. But when you have a lot of people querying nearly the same page at the same time, we are doing the same work for everyone. This is what's not optimal at all. So what we did is transforming our reverse proxy into a proxy cache. The function of the server, the backend server, is exactly the same, except when Alice sends a request, proxy cache sends a request to the backend server works hard, and then the proxy cache remembers the results it sends to Alice, because we hope we'll have many more users like Alice that will ask for the same content, and then we can serve them the same content without computing it from scratch again. And this is what hopefully happens when Bob, just some time after, wants to see the same page. It asks the same query to the proxy cache, and the proxy cache remembers that it already serves this content to Alice before, so it serves the content it already has and sends it to Bob without asking to the backend server. Meanwhile, the backend server has nothing to do about this query, can work on other queries, and we are saving up a lot on CPU power in the backend. So this works great. It's cool. Why didn't we do it earlier? Because actually it's much harder than it seems. The first problem we can have with an HTTP cache is privacy issues. Because if we remember the content we sent to a user and serve it to another user in order to save on the CPU power, the problem is that this content may be private and may contain private data or personal data, for example. And it would be catastrophic, obviously, if we serve the personal content to the wrong user. So the first issue to tackle before putting in place any cache is to check that we never serve any private content to the wrong user. So the solution we chose, because in our case we wanted mainly to cache anonymous content, was to just make sure that we never stored in cache private content. So for example, here Alice asks for logs in on our portal, so she's authenticated. She gets private content that is tailored for her. Maybe she has access to private data. We are not sure, but anyway, the proxy cache knows that Alice is authenticated, so it just does not store the content. This is how we manage to avoid any privacy issue with the cache. This also means that all authenticated content is never stored, so never benefits from caching. It's not a problem for us because we're talking about public content for now. We're just addressing public content with a cache. The next issue is cache invalidation. For example, what happens if you update the content? If you remember, the proxy cache stores the content from a request and then serves it again to another user later. What if the data is updated in between? We will serve outdated data to a user. So the right way to handle this problem is to use cache invalidation. That means when the data on the backend is updated, we should remove outdated content from the proxy cache. Actually, this is a way more complex problem than that, because there are a lot of dynamic content that is generated in all response. So keeping track of which data was used to create which query in the cache is way too complex. So the alternative is just to set a timeout, a time to live. Each content is cached for a certain duration, and then we create it again. So for now, we use the time to live value of 5 minutes, meaning data is kept in cache for 5 minutes anyway. So for example, here, if data has been updated on the backend server by a user, maybe the data source has been changed for any reason, the proxy cache doesn't know about it. And actually, later, another user will query the content. The cache will think it already knows the content, even though it has changed, and will serve to old content. It's a compromise to the duration of the time to live has to be checked, has to be chosen intelligently. It's always a compromise between fresh data and the performance of the cache. Because here, for example, if it's been too long, for example, with a time to live of 5 minutes in the cache entries, the data has been stored for more than 5 minutes, and then another user will request the same dashboard, and then the proxy cache will see that its data it has for this query is too old, So we'll ask again to the backend server for the content. So the backend server will work hard to create again each time the content and give it back to the proxy cache. So actually, when we set a time to live of 5 minutes, the backend server will will compute again all the content every 5 minutes at least. But if we have many users asking for the same content between these 5 minutes, we still have a very good performance of the cache. So it's really a compromise to be chosen between the speed between the data update speed and the traffic and the expected traffic. Finally, there's another problem we need to tackle with HTTP caching. What happens when authenticated users come and ask for content that is already in cache? If we serve content from the cache to an authenticated user, the authenticated user will get anonymous content, but this user may actually have access to more private data. And it will be a disastrous user experience because you're expecting private data that you have access to, and you may not get it and have anonymous content in its place. So it would be really bad. So what we did was just never serve cached content to authenticated users. So actually, the problem behind was that was to identify authenticated users. We had to make some subtle changes to our handling of sessions and the identification, etc., to be able to really find out which users are authenticated or not. So it's been quite a lot of work to go from this, where an anonymous user can request a dashboard, we'll store it in the cache, and we can serve it to other anonymous users. But then when Alice comes and is authenticated and asks for the dashboard, actually she may be an administrator on the portal, she's authenticated, so maybe she should ask, she should have access to more data on this page. So the proxy cache knows about this and always asks for fresh data to the backend server anyway. And moreover, obviously, at the end, as the content may be private, the content is not stored. So authenticated users always bypass completely the cache. So now now that we have tackled all the functional problems with the cache, we know that only anonymous users will get cached content for up to 5 minutes. So they may get a little outdated content, but private content will not be stored. There are no privacy issues, and authenticated users will never get anonymous content. Now the issue is to make the cache worthwhile, because actually, if we did just this, but the issue was that no two requests were actually exactly the same, so the cache was nearly unused. So we had to make sure that two anonymous users actually made the same request, so that the cache could identify them as identical and serve the identical content that it had stored. And this was again much harder than it seemed, because in a request, for example, you ask for content in a specific language. All our queries contain the language of the users, and users may have a list of preferred language, etc., with weights. Just this made a lot of variability in the request. So we had to make the proxy cache more intelligent by identifying combination of languages and mapping them to cached content, so that two people that have subtly different queries still get the same cached content without having the backend server work again for nothing. So this is what we're doing now. When Bob asks for the dashboard, actually the content will be the same, but even if the query is not the same, the proxy cache identifies the differences between the queries and can conclude by itself that the result would be the same if we asked the backend server. So it can still return what is stored in its cache. This is called the work of the normalization. There are a lot of fields in the queries that can change a little among users and queries, and we need to proactively normalize them to standard values so that we can find the right content in the cache. And here the backend server is happy because it can work on something else instead of computing the same content ever again. So the performance of the cache is actually its hit rate. It's a ratio of queries that can be served by content that has already been seen and stored. So when a query is served directly by the cache without asking to the backend server, it's called a hit. When it does not match any content in the cache, so it has to be forwarded to the backend server, it's called a miss. And bypass are obviously all the authenticated contents that must not be served from the cache. And expired, finally, are all the queries that could have been answered by the cache, but the cache content was too old, so we had to ask the backend server for a new version anyway. So this is actually the traffic peak during Junta de Castilla y León COVID data update. So around 1 p.m. every day for a few months. Every day we had this kind of traffic, and once we had the cache, the HTTP cache in place, we could see that during the peak, actually we didn't have much more load on the backend server because most of the traffic was being served by the cache. So this was a real success. So we still have quite a bit of misses, but we can see that the ratio of misses during the peak is lower than during the background traffic. So most of the additional queries during the peak are served by the cache. So it's great because that means we can keep a standard size backend server instead of upgrading it all the same. So the hit ratio is really the key metric to follow on the HTTP cache. Another benefit of the HTTP cache is the response time, because on the left you can see the graph of both in the area the traffic, so the number of queries we get. It's the same as the previous graph. So we see the peak every day at around 1 p.m. when the data is updated, but at the exact peak of traffic, we can see that the server saturated a little, and the response time skyrockets because the server just cannot serve all the queries because there are just too much. After, on the right, this is with the cache, and now we serve as many queries, but the response time stays about flat. And even is lower because most of the queries are served by the cache, and the cache is much faster than asking the backend server for a page. It has to compute in its entirety. We are talking about a factor of 10 to 100 faster. So the load is lower and the response time is much better, and even better as the cache content can also be cached by the browser of the users. It means that reloading the page in a browser is instant. You don't have to wait if you reload, and it also removes a lot of load from the servers because people hitting the refresh button in the browser can generate a lot of load. So if it's handled directly by the browser, it's just a direct win for everyone. So this is everything I had to explain about the cache for now. It was a great project that was a little improvised at the beginning of the year because we just did not expect that much traffic, and it's been a real success because now it can be used on all our ODS domains. So I let Florent finish with the availability and the evolutions of this HTTP cache. Thank you.
Thank you, Julien. So about availability and evolutions. As of today, the features is obviously available on few domains from the platform. We have two main drawbacks we would like to address in the future. First, the cached requests which are solved by the cache, they do not contribute to domain statistics, meaning that if you go in your back office and you check your domain statistics, you won't see the requests that have been served by the cache. So your audience statistics are basically flawed. We really would like to fix that in the future. The second drawback is regarding map views. We have you can add on your pages. They are very hard to cache currently for us. This is related to map content variability, some stuff related to the zoom level, for example, of the map. Well, anyway, this is something we would like to address in the future too. So obviously, if you are already an Opendatasoft customer and think you might benefit such a thing, knowing the drawbacks, you can reach your customer success manager and we can discuss about enabling the feature. That's it for us. So now if you have any question, we can answer about it. Thank you.
So what's the next big challenge in terms of performance management? It's obviously scalability of our backend too. So now we've been able to handle anonymous users on the caching content to better handle large anonymous user traffic, but we also need to handle traffic spikes that that we cannot cache. So it will hit the backend servers. So we need to better handle backend scalability. But this will be a long-term work and with the small steps along the way. And obviously, if everything goes well, you won't see it anyway. That's that's the kind of work we do. When we do our work well, you can't notice it. If you notice our work, it means that we failed because the platform is offline or slow. So hopefully it will stay in the shadows. Well, thank you, everyone.
Thank you. Thanks for watching, and bye-bye.